We will now continue with using equations of motion to solve problems. Let's start with this problem. An object moves in the positive x direction with a speed of 40 meters per second. You can see I gave you the speed and the direction, and the combination is a description of the velocity. As it passes through the origin, it starts to experience a constant acceleration of 3.5 meters per second squared in the negative x direction. How much time elapses before the object returns to the origin? So what happens here is the object moves as it comes to the origin. It has a certain speed, and as it goes to the right, it experiences an acceleration in the opposite direction. So it's going to slow down and move back to the origin. And we want to find what? How much time elapses before the object returns to the origin? It has an acceleration directed in the negative x direction, means it's going to go to the right and come back. Just like an object thrown up, you see that? Why it goes up and comes back? Because there is an acceleration directed in the opposite direction. Alright, let's write down the given data. Here we have the origin, and this is the position x equal to 0. And when the object or the particle comes at the origin, it has a velocity. So v0 is 40 meters per second. When the object reaches the origin, it has a velocity of 40 meters per second directed in the positive x direction. And it has an acceleration of negative 3.5 meters per second squared directed opposite. You can see velocity is in the positive x direction, acceleration is in the negative x direction. Now, so what does it do? It will go to the right to a point here, it will then come back. Let's use the equation x equal to v0t plus 1/2 at squared. Now tell me, the object which is initially at the origin goes to a certain position and comes back. What is the value of x, the displacement, when the object comes back to the origin? Well, the displacement when the object comes back to the origin will be 0. So we need to find the time t for this displacement x to become 0. We know the initial velocity, we know the acceleration, we need to find the time t for this displacement to become 0. I hope you understand this. We have been told to find the time taken by the object to go to the right and come back to the origin. And when it does so, its displacement becomes 0. So the question is, find the value of this time t when x equal to 0. So there we say 0 equal to 40t, v0 is 40, plus 1/2 a is negative 3.5 t squared. And let's rearrange this equation. 1/2 times negative 3.5 is negative 1.75 t squared. So 40t minus 1.75 t squared is 0. Or I'm going to change the sign of everything. 1.75 t squared minus 40t equal to 0. I hope you understand. I just rearranged that equation. I took all these terms to the left and made the right side 0. The negative 1.75 t squared goes to the left, become 1.75 t squared minus 40t equal to 0. Can you solve this equation for t? All you need to do is factor out a t. So t factored out, t times 1.75t minus 4t equal to 0. And now you set each factor to 0. That means one value of t is t equal to 0. And the other value of t is obtained by setting this factor, 1.75t minus 4t equal to 0. And when you do that, it will look like this. 1.75t minus 40 equal to 0, or 1.75t equal to 40, or t equal to 40 divided by 1.75. Is that right? And that will give you t equal to 23 seconds. So you have two values for this t. In other words, we are told that this x will be 0 for two values of the time. When t equal to 0, that is when the object is at the origin in the beginning. So x equal to 0 when you start at t equal to 0. And x will be also equal to 0 after 23 seconds. That means that 23 seconds is the time taken to go to the right and come back. Okay. So this means that the object is at the origin at t equal to 0 and returns to the origin after 23 seconds. That's a very good problem. Practice that. Alright, look at this now. Sketch the general form of the graphs of velocity versus time t and y versus t for an object that is projected vertically upward. Now, how does the velocity of an object that is projected upward change? Can you talk about this in your mind? You see, in order that an object may go up, well, in order that the object may go up, you got to give this object an upward velocity. That means the initial velocity is directed upward, means it is positive. What happens to the velocity as it rises? It becomes 0. And then the velocity is going to be downward. That means it is going to be negative. You see that? So the velocity starts at a high value. In order to make it go up, you got to give it a high velocity. So velocity, the initial velocity is a large velocity. And with time, the velocity decreases to 0. And then the velocity goes in the negative direction. Is that right? That is how the velocity changes with time. Alright, so how do we plot a graph of velocity against time? V0 is the velocity of projection. When you throw it up, the moment you throw it up, it has a velocity V0. And what happens to it with time? The velocity decreases. The velocity of projection is V0. The velocity decreases and becomes 0 at the highest point. And then it goes in the negative direction. Look at this. The velocity from V0 decreases to 0. And where is the velocity 0? At the highest point. And then on, the velocity increases in the negative direction, where that means the velocity decreases. So how will the graph proceed from here? Alright, anybody tell me how is the graph going to go from here? It's going to go this way. That is the graph there. So the velocity from V0 decreases to 0, and then it decreases, you see, because it is negative, it continuously decreases to a velocity negative V0. So if I throw this up with an initial velocity positive V0, when it comes back, its velocity will be negative V0. You see that? The speed with which you threw up will be equal to the speed with which it returns. but the directions will be opposite. So the velocity against time for an object that is thrown vertically up. All right. How does the position y change with time? Can you talk about this? How does the position y change with time? Well, let me see if I can illustrate that to you. You see, if the position changes by this much in the first second, in the second second the position will change only by a smaller amount, because as the ball keeps going up, its speed is reducing. That means each second the position changes by smaller and smaller quantity. That means as time increases, the distance covered becomes smaller and smaller. So what will happen to the graph? If you draw a graph of y against t, what will be the shape of that graph? Can you think about it? All right, we talked about this velocity. When it returns, its velocity will be equal and opposite to the velocity of projection. All right. Okay, let's now talk about the y while going up is positive. You know that we can actually do it right here. The displacement is given by the area under the velocity graph. So this is the velocity of the object while going up. At the maximum height, the velocity is 0. If you measure the area under that graph, it will give the displacement while going up. So look at that, I shaded that area. This area represents the positive displacement while going up. And now, this is the velocity while it is coming down. The velocity is 0 at the highest point and goes in the negative direction. And if you measure the area enclosed by that, all right, the displacement y each second is smaller than the previous second. Is that right? I told you as each second as it goes up, the displacement gets smaller and smaller. So what shape will the graph take? Right, you know, if I want to draw a graph of y against t, if it has to be a straight line, it means each second the displacement is the same. If each second the displacement is the same, you get a straight line graph. Now what happens when you throw an object up? Each second the displacement becomes lesser and lesser as the time goes on. That means the graph will curve down. So your displacement graph will be a concave down graph. You see that? So while going up, the value of y will be positive. The displacement y each second is smaller than the previous second. Look at that. Therefore, this will be the graph of displacement against time. You can see if in the first second it went up 3 meters, in the next second it goes up only 2 meters, in the third second it goes up only 1 meter. Each second the distance it travels becomes lesser and lesser. So the position against time is a concave down graph. Now, one thing you must understand if you have learned your calculus well, if the acceleration is negative, in this case the acceleration is negative, then the graph of the position function will be concave down. On the other hand, if the acceleration is positive, the graph of the position graph will be concave up. Okay, we will talk about that as we go on. Now, y while coming down is negative. The displacement while coming down is negative. Now this is the negative displacement while coming down. What is the total displacement for the whole journey? You can see an area above the x-axis is positive, the area below the x-axis is negative. That means if you add these two, what do you get? 0. So the total displacement is 0 in this case. You can see the position, the total displacement is 0. Let's do another one. Sketch the general form of the graphs of position x versus time t, velocity v versus time t, and acceleration a versus time t for an object moving with positive velocity and positive acceleration. Well, positive velocity and positive acceleration. It means the velocity is continuously increasing. The position is increasing every second. So, if the acceleration is positive, the position graph will be concave up. Well, let's look at this. Here is the case of the object that is moving with positive velocity and positive acceleration. Look at this. If this is the displacement in the first second, this is the displacement in the third second, the displacement each second is greater than the previous second. That means the graph will be concave up. So x against t, it will be concave up. Each second the displacement is greater than the previous second. The position graph is concave up. How about the velocity graph? Because the acceleration is positive and uniform, the velocity will keep on rising. It will be a straight line, and the slope of the velocity graph will be the acceleration. How will the acceleration change? The acceleration will be uniform and positive. You can see how the displacement changes, how the velocity changes, and how the acceleration changes for a particle moving with positive velocity and positive acceleration. I want you to learn these descriptions. Alright? Now, I have an animation that is given on this website. I would like to acknowledge each time I use a borrowed animation. Now, watch this animation. You can see positive velocity, positive acceleration. You can see these dots get farther apart. And look at how the position function is graphed. It's a concave up graph. Velocity increases uniformly and acceleration remains a constant, namely 2 meters per second squared. Alright? Okay, let's move on and look at another case. Alright, sketch the general form of the graphs of position x versus time t. You need to sketch the position graph, sketch the velocity versus time graph, and acceleration against time of an object moving with positive velocity and negative acceleration. Alright, positive velocity and negative acceleration. Can you tell me what that's going to look like? Well, look at the positions of the object. What happens? Because you have a negative acceleration, the displacement each second is smaller than the previous one. Because the object has a negative acceleration. So, if the acceleration is negative, if you plot a graph of, if you look at this, if this is the displacement in the first second, displacement in the second second is smaller, displacement in the third second is even smaller, each time the displacement gets smaller and smaller. So the position graph will be therefore concave down. That's the graph of position against time, how will the velocity change? Well, velocity is positive and decreasing, is that right? Because the acceleration is negative, the velocity is positive and decreasing. You see that? And what would be the acceleration against time? Acceleration is uniform and negative. The acceleration is negative, the velocity decreases. You can see, if you measure the slope of this graph, that should be a measure of the acceleration. And now, what will be a plot of acceleration against time? Can you help me do that? Acceleration is negative and remains a constant. So it will be a horizontal line below the time axis. So this is how the position changes, this is how the velocity changes, and this is how the acceleration for an object that is moving with positive velocity and negative acceleration. In fact, this is the case when the object is thrown up until it reaches the maximum height. You see that? That's the same case here. Alright, let's now look at the same case, a web animation. You can see positive velocity, negative acceleration. Each second the displacement gets smaller and smaller. The position graph is concave down. The velocity decreases to 0. And the acceleration is a horizontal line below the time axis. The acceleration is negative, therefore the velocity decreases. The displacement each second is smaller than the previous second, therefore the graph will bend down. And of course the acceleration is negative, means it will be a horizontal line below the time axis. Look at one more case. Sketch the general form of the graphs of position x versus time t, velocity versus time t, and acceleration versus time t. Look at this carefully. Of an object moving with negative velocity and positive acceleration. Well, negative velocity and positive acceleration. Can you think about this? In other words, the object is moving in the negative x direction, negative velocity, and the acceleration is positive. This is opposite to the first one we did. Alright, let's look at the position. It is moving in the negative x direction, and there is an acceleration directed in the positive x direction. That means the displacement is getting smaller and smaller, but there's a difference. The displacement is getting smaller and smaller in the negative x direction, not the positive x direction. Is that right? Yes. Therefore, what will the graph look like? So this is the direction of the velocity, and the direction of the acceleration is opposite. Now, the displacement each second is smaller than the previous second. But actually, that statement is strictly not correct. Because these are negative, then when a negative number becomes smaller, its value is increasing. Actually, the displacement is getting bigger each second. Is that right? Because negative 2 is greater than negative 5. That means if this is negative 5 and this is negative 2, this is greater than this. So, what would be the graph like? Alright, look at the graph there. The graph is concave up. The acceleration is positive. Whenever the acceleration is positive, the position graph will be concave up. In other words, it is like this. You see, this is the graph of position against time for an object that is going to the right with a negative acceleration. You see that? Now, if you simply reflect it, it will give you the case here. If you simply reflect it, you get this graph. So this is the position against time graph. And how will the velocity against time graph look like? Velocity is negative and increasing, isn't it? Tell me, is the velocity increasing or decreasing here? If the velocity decreases, it will keep on going in the negative x direction. But because it's got a positive acceleration, the velocity is actually increasing, and that is why eventually it will turn back. So how will the velocity look like? It starts with a very large negative value, and the velocity gradually increases to become 0. So look at the velocity graph. The velocity is negative, increases to become 0. And what is the acceleration? Acceleration is positive and uniform. Alright? I want you to watch these one more time. Get these concepts clearly understood. Alright. Again, I have an animation of the same concept. An object moving to the left, negative velocity and positive acceleration. Look at that. The position function, the velocity function, it starts at negative 20 meters per second and increases to 0. And the acceleration is positive and uniform. Okay, let's move on. Let's do a problem. A ball is thrown upward with an initial velocity of 20 meters per second. A. How long is the ball in the air? A ball is thrown up with a velocity of 20 meters per second. It goes up and comes back to the same position. How long is the ball in the air? What is the greatest height reached by the ball? And see, when is the ball 15 meters above the ground? Okay, let's see. Can you do this, the first part, on your own? We have done problems like this. How long is the ball in air? The ball is initially here, it is thrown up and it comes back to the same point. How long is it in the air? What that means is, what is the time taken for its displacement to become 0? Is that right? When it comes back to the initial position, its displacement becomes 0. So the question here is, how long is the ball in the air means, what is the time taken for its displacement to become 0? So you can actually do that right from the displacement equation. Alright, let's write down the given data. Initial velocity is 20 meters per second. That's the velocity of projection. Acceleration, remember, anything that is thrown up, the moment it is released, its acceleration is directed downward and is equal to negative 9.8 meters per second squared. So, its initial velocity we know, its acceleration we know. The position function for the ball thrown vertically up. What is the position function for the ball that is thrown vertically up? What is the displacement equation? Y equal to, for vertical motion we use Y. Y equal to V0t plus 1/2 AT squared. And in place of A, we will use negative G, that is negative 9.8. So Y equal to Y0 plus V0t minus 1/2 GT squared. And Y0 is 0 because we projected the ball from the origin. So Y0 is 0. And I want to add a word of caution here. we have used here the negative sign. It is this negative sign we have used. So once we have used the negative sign, don't use the value of g to be negative again, because it is this value of g that made that sign negative. And so what will you now use g equal to? G equal to positive 9.8. On the other hand, if this you keep it as positive, then a will be replaced as negative g. So I hope you understand it. We have used the equation minus 1/2 gt squared. So you will not use that negative again. Okay, here y0 equal to 0. When the ball comes back to the ground, y will be equal to 0. Is that right? When the projected ball comes back to the ground, y will be equal to 0. So in this equation, we are going to set y equal to 0. y0 is 0 because it's the origin. And then we will replace our g by 9.8. We will replace our v0 by 20 meters per second and solve for t. That is what the problem is. Okay. So we have 0 equal to 0 plus 20t minus 4.9 t squared. You can now solve this equation. Or 20t minus 4.9 t squared equal to 0. Or I moved all this to the left. It will be 4.9 t squared minus 20t equal to 0. And I factored out the t. You see, this is the step before that. I wrote it like this: 4.9 t squared minus 20t equal to 0. That is, took this to the left, became positive. Took this to the left, became negative. And the right side is 0. And then I factored out a t from there. It gives me t times 4.9t minus 20 equal to 0. And now set each factor to 0. It gives you the first value of t is t equal to 0. And the next value, you set this factor to 0, 4.9t minus 20 equal to 0, and solve for t. What does that give you? You see, for those who are not following this, I set the second factor to 0, 4.9t minus 20 equal to 0, or 4.9t equal to 20, or t equal to 20 divided by 4.9, which is 4.08 seconds. Again, we have two values of t. Why are there two values of t? The first value is just when it begins. At t equal to 0, y equal to 0. And after a time t equal to 4.08 seconds, again y equal to 0. That means the time taken to go up and come back is 4.08 seconds. Well, we're going to use one more concept here. If the time taken to go up and come back is 4.08 seconds, what is the time taken to go to the maximum height? The time taken to go to the maximum height is half of this time, which is 2.04 seconds. And the time taken to come back is another 2.04 seconds. That's very important. The time taken to go up equal to the time taken to come down. All right. Let's do B now. B, what is the greatest height reached by the ball? Well, in order to find the greatest height reached by the ball, we need to know the time taken to reach the maximum height. Well, if t equal to 4.08 seconds is the time taken to go up and come back, What is the time taken to reach the maximum height? Will be half of that. So the time taken to reach the maximum height is half the time taken to come back. So we have t equal to 2.04 seconds, the time taken to reach the maximum height. Therefore, y max will be y of 2.04. In other words, if you write y as a function of time and put that time equal to 2.04, you will get the value of y. Can you give me the equation for y? Y of 2.4 is v0t minus, look at this, we have y of t equal to y as a function of t equal to v0t minus 1/2 gt squared. You see, y of t is v0t minus 1/2 gt squared. v0 is 20 meters per second. The time taken to reach that maximum height is 2.04 minus 1/2 of g. G is 9.8. 1/2 of 9.8 is 4.9 t squared. You can see that is what this step is. Y of t equal to v0t minus 1/2 g times t squared, and we replaced our t by 2.04 seconds. And what does that give you now? Where is the object at the end of 2.04 seconds? That is 20.4 meters. So at the end of that 2.04 second, it is at y equal to 20.4 meters. I hope you understood we saw solving that problem. The position of the object at the end of that 2.4 seconds can be obtained by using t equal to 2.4 seconds in the position function of the object. Now see, when is the ball 15 meters above the ground? In other words, what is the time taken by the object to be 15 meters from the ground? That means here we need the time when y equal to 15 meters. So here again we will write the position function. What is our position function? Y of t is v0t minus 1/2 gt squared. That is the position function. And so we will write, let me write that position function for you. So my position function is y of t equal to v0t minus 1/2 gt squared. Now what are we supposed to find? We are required to find this value of t when this y equal to 15 meters. That is what this c means. When is the ball? What is the time for the ball to be 15 meters above the ground? The value of y is 15 meters. So 15 equal to v0t, 20t, minus 1/2 g is 4.9 t squared. Alright, can you solve that equation? Rewrite this equation as a quadratic equation. You can move both these terms to the left and make the right side 0. So that will become 4.9 t squared minus 20t plus 15 equal to 0. That is a quadratic equation. And you all know how to solve a quadratic equation. I'm going to leave it for you. Is that right? Well, you know this is a quadratic equation with a equal to 4.9, b equal to negative 20, and c equal to 15. So t will be negative b plus or minus square root b squared minus 4ac all over 2a, and that will be negative b. b is negative 20. Negative of negative 20 plus or minus square root b squared is negative 20 squared minus 4 times 4.9 times c is 15 all over 2 times 4.9. Alright, I'm going to leave that for you to do. You will get two values of time, and I got them as t equal to 0.99 second and t equal to 3.09 second. Now tell me, why do we get two values of time? Well, we get two values of time because the ball gets to a height of 15 meters once while going up and while coming down. You see, two times the ball becomes at a height of 15 meters from the ground. Okay, let's do another one. With what speed must an object be projected vertically upward for it to reach a maximum height of 120 meters above the ground? We want an object to reach 120 meters above the ground. What should be the speed with which you need to project it upward? I want you to think about this problem. Can you write down some of the known data here? What do we know? Well, we know we are looking for v0, the initial velocity of projection. What else do we know? Anything that is projected up, you should know has an acceleration of negative g. That is negative 9.8 meters per second squared. We know its acceleration. What else do we know? Well, you know its displacement. You see, y equal to 120 meters. It is at the position y equal to 120 meters. So, we know the acceleration, we know the displacement, we know one more thing. What is that? When the object reaches the maximum height, its velocity becomes 0. Vf equal to 0. Alright? Well, okay. At the maximum height, the velocity of the ball equal to 0. Is that right? If you throw something up, its velocity decreases, the velocity becomes 0 at the maximum height. So, Vf equal to 0. And we need to find the V0. Can you tell me what equation you will use there? We don't have time here. Obviously, we are looking for an equation that does not contain time. Alright? We got Vf equal to 0. We are looking for V0. Look at the equation we are going to use. The third equation. Vf squared equal to V0 squared plus 2ay. Vf is 0. We need to find the V0. A we know equal to negative 9.8 and y we know is 120 meters. Alright, let's put all those values there. 0 equal to V0 squared plus 2a. A is replaced by negative 9.8. Y is replaced by 120. And that is 0 equal to V0 squared minus, multiply these numbers, that is 2,352. Or V0 squared equal to 2,352. Square root of that is 48.5 meters per second. In order that an object may reach a height of 120 meters, you need to project it up with a velocity of 48.5 meters per second. Now watch how we do these problems that become so simple when you know how to figure out the data and the equation that will help us to solve it. Okay? Practice this. Only practice will make you perfect in solving problems like this. Okay, another one. A stone is thrown vertically downward with an initial speed of 12.5 meter per second from a height of 65 meter above the ground. That means it is thrown from somewhere above the ground. So that is your y0. y0 is 65 meter. When time equal to 0, the position of the ball is y equal to 65 meter. How far does the stone travel in 2 seconds? And what is the velocity when it hits the ground? Okay, can you help me pick the data? It's not very difficult. And a stone is thrown vertically down with an initial speed v0. Well, v0 equal to 12.4 meter per second from this position. y0 is 65 meter. This is where it is going to be thrown from. And it is at a height of 65 meter. And initial velocity. Now look at the negative sign. Why did I use the negative sign? Because it is downward. So v0 is negative 12.4 meter per second. It is directed downward. There, that is the initial velocity. And the acceleration is negative g, negative 9.8 meter per second squared. You see, you need to figure out these given data. Okay, we need to find the position. How far does the stone travel in 2 seconds? In other words, in 2 seconds it travels, say, up to here. We need to figure out that distance. And for that, we will first find the position at t equal to 2 seconds. Where is the object at t equal to 2 seconds? We will use this equation. Y equal to y0 plus v0t plus 1/2 at squared. Do we know all these quantities? Yes, we know y0. There you are. We know v0. We know a. And we know t. So use all those values there. That will be 65 plus. v0 is negative 12.4 times 2 plus 1/2. A is negative g, negative 9.8 times 2 squared. Do that calculation on your own. Alright, always check my calculation because I sometimes make mistakes. Or maybe very, very often. So don't leave any calculation to me. Always do it on your own and check it. That will be 65 minus 24.8 minus 19.6. That is 20.6 meter. In other words, at the end of 2 seconds, the object is at y equal to 20.6. So it is here. This is 20.6 meter. Don't confuse it. This 20.6 is not the distance it has fallen. At the end of 2 seconds, its position is y equal to 20.6 meter. This one. And that means the answer to the question is, how far does the stone travel? It traveled this far. That means the whole distance is 65, and at the end of 2 seconds it is at y equal to 20.6 meter. Therefore the distance it travels during that 2 seconds is 65 meter minus 20.6 meter. That will be 44.4 meter. That is how far it drops in 2 seconds. Alright, the next one. What is the velocity when it hits the ground? Well, we know the initial velocity, we know the acceleration. We need to find the final velocity. We know the displacement. Do we know the displacement? Yes. It traveled from y0 equal to 65 to y equal to 0. Can you figure out an equation that can be used here to find the velocity at the end when it hits the ground? To find the velocity of impact, we use y equal to negative 65. Why do we use y equal to negative 65? Because the particle or the object or the stone now travels a distance y equal to negative 65. It is going downward. It covered a distance 65 meters downward. So we use y equal to negative 65. In the equation, Vf squared equal to V0 squared plus 2ay. Well, we need to find the Vf. What's the velocity when it hits the ground? We know V0, we know a equal to negative 9.8 meter per second squared. Y equal to negative 65. Alright, that gives you Vf squared is V0 squared, negative 12.4 squared, plus 2 times, in place of a I wrote negative 9.8, in place of y I wrote negative 65. And that, you can see negative, all this becomes positive. Vf squared is 1427.76, or Vf is square root of that, that is 37 meter per second downward. Okay, let's do another problem. A bullet traveling at 350 meters per second strikes a telephone pole and penetrates a distance of 12 centimeters before stopping. A. Estimate the average acceleration assuming it to be constant. B. How long did it take the bullet to stop? Right, if you follow everything that we did so far, you can do this problem on your own. A bullet strikes a telephone pole. The instant when it strikes it, it has this velocity, 350 meters per second. That's the initial velocity. And it penetrates into the pole and stops. Is that right? Yes. What is the velocity when it stops? 0. And it travels this distance, 12 centimeters in stopping. You know the displacement. You know the initial velocity. You know the final velocity. You know the displacement. Can you find the acceleration? All right. V0 is 350 meters per second. X equal to 12 centimeters. That is, from V0, its velocity becomes 0 in traveling a distance of 0.12 meter. And Vf equal to 0. We need to find the acceleration. Look at this. Again, the equation that does not contain time. We know Vf, we know V0, we know X. We can find A. So use all those values. 0 equal to 350 squared plus 2a times 0.12. Solve for a from there. 0.24a equal to negative 122,500. Or a equal to, look at this acceleration. A equal to negative 5.1 times 10 to the 5 meter per second squared. Why is the acceleration negative? Because the bullet strikes and it is brought to rest the acceleration is opposite to the velocity. The acceleration is negative. The bullet has a tremendous acceleration, and that is the reason why a bullet can kill, because of the tremendous acceleration it has when it hits. What's the next part? How long did it take the bullet to stop? You see, now that we know the acceleration, we know the initial velocity, we know the final velocity, we can find time using the first equation. Vf equal to V0 plus AT. Is that right? Yes. And we know all these values. Vf is 0, V0 is this, A we just calculated, we can therefore find time. So 0 equal to 350 plus A times T. Can you calculate that time? This is a negative quantity, which when you take it to the left becomes positive. And so T equal to, you can see 350 divided by this number, which gives you a very small number. T equal to 6.9 times 10 to the negative 4 second. Is that right? It's a very small amount of time. That is about 0.69 millisecond. 0.69 millisecond. Is that right? Did you figure out if I get this right? Actually, 6.9 times 10 to the negative 4 is the same as 69 times 10 to the negative 3. And 10 to the negative 3 is a milli. So it is 69 milliseconds, not 0.69. So make that correction there. Okay, let's do another problem. A car traveling at 15 meters per second is brought to a stop at a constant deceleration. A deceleration is a negative acceleration. 100 meters from where the brakes are applied. What is the time taken by the car to stop? How far has the car moved when its speed has been reduced to 10 meters per second? Alright, what do we have? We got V0 is 15 meters per second, is brought to a stop, means Vf equal to 0. At a constant deceleration means the acceleration is negative. 100 meters from where the brakes are applied. That means velocity from 15 meters per second becomes 0 during a displacement of 100 meters. X equal to 100 meters. What is the time taken by the car to stop? Well, here's a little problem. We have V0, Vf and X. Well, is there an equation that connects V0, Vf, X and the time? We need the time. There is no equation that contains all these three. And therefore, what you need to do is, if you know V0, Vf and X, we can calculate the acceleration. So we will do that first. First we obtain the acceleration A using what equation? The one that doesn't contain the time. Vf squared equal to V0 squared plus 2ax. That is 0 equal to 15 squared plus 2a times 100. And solve for A from there. You get A equal to negative 1.125 meter per second squared. Well, once you have the acceleration, we can now use these values of V0 and Vf and this A to find your time using what equation? Equation number 1. Vf equal to V0 plus AT. We have Vf equal to 0, 0 equal to 15, plus A equal to negative 1.125 times t, and solve for time from there. That gives you t equal to 13.3 seconds. You can see that's a two-step problem. You got to use the given data to find the acceleration, and then use the acceleration to find the time. Alright, what's the next? How far has the car moved when its speed has been reduced to 10 meters per second? Well, this time, this is your final velocity. You see, you must now know the acceleration we know, the initial velocity we know, the final velocity here is given to be 10 meters per second. We need to find what? How far has the car moved? Find x. Alright, so for that part, V0 equal to 10 meters per second. Now, this is not what we need. We need Vf equal to 10 meters per second. This is the acceleration. We need to find our x. When the speed is reduced to 10 meters per second, we have Vf equal to 10 meters per second. And now we use the equation. Which equation? We are looking for x. Is that right? Yes. Vf squared equal to V0 squared plus 2ax. Vf you know, V0 you know, acceleration we know, and therefore you can find your x. Alright, I'm going to leave it for you. I will just show you the steps, simplify this, and solve for x. Alright, that gives you x equal to 55.5 meter. Now you need to do all these problems on your own. Okay? Alright, let's do one more problem. We have now done a number of representative problems using equations of motion. And in order to be very familiar with it, you got to go back and do all the homework. You see, only by practice you become perfect. And if you need to really enjoy physics, you need to understand these concepts. Now, very often I notice that students do poorly in conceptual questions. You need to understand the basic underlying factors in these simple processes. You see, the nature obeys very simple rules. And if you understand those very simple rules, you can understand nature in a very intimate way. And once you understand, you can enjoy nature. And solving problems using the phenomenon in nature becomes a joy. Alright? So, solve these problems in the homework and let me know if I can help you with more information or anything else. Okay, I will see you for the next lesson, lesson 3, later on.